Thank you very much, Long, and it's really my honor to join the panel of distinguished economists. So, as someone who has been working in the AI for the last 30 years, I would like to share my recent observation on the new development of AI models, specifically the models that are released in the last 3 weeks from two leaders, leading companies in this field. And I'll cover most on the technical issues. Then I will touch on the impact of this new development on the economy and on the future society. But first, let's look at the two pieces of news that happened in the last 3 weeks. First one is the Gemini 3 that was released about 3 weeks ago. It's really opened a new era for the LLM, or for large AI models. And let me quote Demis, who is the CEO of DeepMind, say that it is the best model in the world for multi-model understanding and powerful agentic and vibrant coding. All built on the foundation of state-of-the-art of reasoning. I would like you to remember those keywords: the multi-model, agentic, vibe coding, and reasoning. So here we don't see many words on pre-training, but later on we'll come back to that. But one thing I do want to point out, the Gemini 3, it's rated as it has the multi-model reasoning capability with a PhD level intelligence, and it also has so much advanced feature on 2Us. Those are all key features for agentic AI, which is what we talk so much lately. And here we can have a quick look on the benchmark performance numbers. We don't have to get into this, and those you can get it on the web. But really, you look through them. It actually across the board, the performance on all the benchmarks have surpassed all the existing model. I mean, basically state of art, with a large margin, sometimes doubled. So that shows this is a significant improvement and significant progress. And this is the first time people also realize Gemini model is good, if not much better than all the existing models, including GPT 5.1. And there is one particular version of Gemini 3, which is the DeepSync, which is the reasoning model and has a strong, very, very strong agentic capability. Just look at the three benchmarks. It's it's better than all other models, and it's including the Gemini 3 Pro. But this emphasizes so much on deep thinking, and it's emphasized on its reasoning capability. And if we look at this chart, just illustrate in this particular what we call the humans lost challenge exam, and you can see that the Gemini DeepSync, that performance is more than double of other models, other existing models. Of course, if you look at the cost, of this particular model, when we come to ask it to perform a given task, the cost is also more than double. It's actually 10 times, if not 100 times higher than the other models. So it has a much strong capability, and of course, it will also require much bigger resource. So let's move to a second piece of news, which is released about a week ago, and here we see the latest model from DeepSeek, which is their V3.2, the model that is a really beautiful agent. So again, it's agentic, focus on agentic capability, and if you read its tech report, it says this is a model with superior reasoning and agent performance. Again, it's focusing on reasoning and agentic performance. And here we want to point out two other key points. One is this particular model, the performance is a result of scaling post-training compute. It's a result of scalable agentic post-training. So here, if you look at the numbers, it's all come to close to the state of art. Why it's important? The model is only come close to the best model, but it's still significant. I'll come back to that because the one key element of its significance is actually the cost efficiency in achieving those performances. So now I briefly mentioned the two pieces of news, basically two latest release of AI models that represent the state of art. And there are few observations I'd like to share with you. And number one is people have been questioning, has the scaling law hit a wall? Is the scaling law still effective? Well, those two models those two releases of the latest model actually answer this question very positively, meaning that we are still far from hitting a wall. What exactly is the scaling law? Well, this is the essence of LLM. That is the emergent abilities from scale. When you scale the data size, when you scale the training, when you scale the model size, performance improve exponentially. And it reached to a turning point. We call it the point of emergent capability that appears. So that explains why our model it become bigger, more powerful, consume more electricity, consume more data. Okay, that's the essence of pre-training. And people start worry that pre-training has hit the wall. But let me quote the two tech leaders of these two models, Gemini 3 and DeepSeek 3.2, V3.2. And the Oriel, who is the tech lead for Gemini 3, basically says that contrary to the popular belief that scaling law is over, and the team has delivered a drastic jump. And this data actually shows that pre-training has a long way to go. Not only that, post-training is still a total greenfield. And similarly, if you look at what claimed by DeepSeek, it emphasizes that computational budget is actually a limiting factor. If they could get more computing power, their reasoning model could go even further. So what they say is that because fewer total training flops, their model is still behind the leading close models. DeepSeek is an open source model, and they are going to scale compute, and of course that will scale data as well, and to make their future model much more much stronger. So, following those two pieces of news, two releases, the OpenAI's research chief also had a interview and made it very clear, you know, scaling law is not dead. It's still strong, and a much stronger model has emerged when after they resumed pre-training. So what I want to say here is, I mean, this particular curve, again, being proved by the latest development in the AI models, that is, not only pre-training scaling law continues, but also we see a new scaling law, which is the reasoning model, the post-training scaling law, just started. And in the future, when we look into memory, we look at the context, when we look at new agentic capabilities, we feel we're going to see new scaling laws, and not only in the post trading stage, but definitely in the reasoning stage, and especially when we think about future agentic capabilities. Scaling law will continue, if not only in the pre-training curve, but definitely more in the post-training, in the reasoning, in the agentic stage. So the one thing that could limit the scaling, I mean, apart from the factor we all know is energy consumption, is the lack of training data. That is a bottleneck. And so I mean, number two observation, that is the question, will AI's industrial scaling up continues? Here we really talk about huge investment into CapEx. That, you know, if we notice what those super scalers, those Amazon, Alphabet, Microsoft, Meta, OpenAI, how much dollars they put into CapEx, which means really data centers, computer centers, in 2025, I mean, in this particular year, and what they're going to continue putting in 2026 and all the way to 2028. We're seeing that this year the capex is over $1 trillion, and projected. Then by 2028, we're talking about those superscalers is going to bring online 5 gigawatt scale training clusters. So, and if we continue this trend, and then we are actually going to hit the problem of power shortage, and that is real, and that's that's where we have heard so much talk lately on when people compare China and the U.S. Well, U.S. are leading in technology breakthroughs. When we talk about energy, talk about electricity, China has progressed much faster than the States. So the question is this projection going to continue? But if we believe the scaling law is going to continue, and this projection is going to continue, so we are going to face energy shortage, at least in the States. And what's the reason behind that? I mean, the two previous speakers already talked about this is really a new revolution. And if we only focus on information revolution and think about the past 4 waves, the mainstream computer, the PC computer, and the web internet, and the mobile internet. Talk about those 3 waves. Every wave, about 10 to 15 years, and they brought in a new set of platforms and come with it new infrastructure and new ecosystem. And of course, the tons of investment. That there should be no difference. There should be no difference for this wave of tech revolution, which is generative AI, and it's really new inflection point. What I'm saying, what I'm challenging everyone to think about, this is not just another wave, in information technology only. It's actually a revolution that can be comparable itself to industrial revolution. And so it's not just another wave, we see the curve goes up. It could be the curve goes up much sharper. So it is, in my view, the most profound technology. And it's something that can compare to fire and electricity. So that will call for a total new build up of infrastructure, like what we did, what the U.S. did when they started build a railroad, 150 years ago, like what we did, 25 years ago for the internet. And this, if we compare the total infrastructure capex we have invested in, we're going to invest in, and we talk about 1.2%. But if you think about, we are building a total new infrastructure, new digital infrastructure for next 10 years, next 20 years, or next 50 years, and this is not a huge investment. If you would look at the scale, look at the impact, the fundamental impact that we're going to see in the coming years. So also, if we look at it today, if we look at the last 2 years and look at the last 12 months, the last 6 months, well, people worry about a bubble in capex investment, and what we see is the demand has far exceeded supply, and all the AI companies, they don't have enough GPUs to provide to their users, to their own researchers, to their own engineers who are training large models, who are provide AI services to their customers. So demand is there, and if that is today, but if we look into the future, if we look at the history, we know what we are. If we believe we are building a new digital infrastructure, our investment today are far from bubble. So the other observation I would like to share with you is the turnaround of Google models of the Gemini 3, and it's a factor that it was trained on their own TPU, on their own chips, not on NVIDIA's GPUs. That could be a beginning of a new ecosystem. If we look at an AI model ecosystem, so we have this, companies that provide models. So they will provide model as a service, and really in the future, a model itself will become part of the platform. And beneath that, in the very foundation is the computer hardware, which is the chips, which in this case is GPUs. And on top of that is a cloud platform. But if we look at the past 5 years, all the money, all the profit actually, gone to one company, which is NVIDIA. So, but the question is this going to change with the release of Google's Gemini 3 and the fact that it's trained on its own TPU? So if we look at the left side, which is the foundation of today's AI model ecosystem, so it's all based on a GPU from NVIDIA. So GPU has a huge margin, and so that NVIDIA made a lot of profit. But then the GPU is more efficient because it really is made for AI, for AI training and for reasoning. So you could see the pricing could come down, and not to mention the fact that it is more efficient when it comes to training, and definitely in the future in the reasoning. So we are seeing a end-to-end, a closed ecosystem that start emerge, especially if you look at all other product that Google offers. So it has AI application, and it has all the existing applications that would be powered by AI. Not to mention in the future, they could come out with AI native apps. But even the existing apps that will be powered or has been powered with their models, that itself is already powerful. And then think about the model itself and the TPU that come with it. So that's more like a closed ecosystem emerging. So in the sense, we already see a kind of open ecosystem which has the NVIDIA GPU at the center. So that was more like an Android system, and more like in the PC time, the Wintel system. But now you have a emerging, end-to-end system that will be more like iOS and Apple's iOS system in the mobile internet time. So, well, which one will win? Oh, in the future, we're going to have two ecosystems, like what we have observed, have experienced in the mobile internet age, in the web internet age. So that's a question. And the other observation, and actually with more confirmation for me, I would like to share is the tech development path that I have always been promoting. That is the AI models, the AI technology is going to go through this path that is from pre-training to the post-training, which is reinforcement learning, and to reasoning model, and to agentic AI. So basically, if you look at what user will have, you have the base model, then you go to reasoning model, then now you have agentic inference engine. So in the sense that the base model, which is the pre-training model, is more like the fast thinking in our brain. So that's system one, but really the most powerful one is the system two, that is, what we call slow thinking, but really more sophisticated thinking. And also, when we come to reasoning model, when we come to reinforcement learning, when we come to agent inference, we are also moving from static machine learning, which is pre-training only, to adaptive machine learning, which will gradually provide the capability to learn from experiences, to continuously adapt to and improve the performance. One particular, approach, a training approach I really like and want to share here is, what has been promoted in the reinforcement learning field. That is, you don't teach, you incentivize. In Chinese we say, 授人以鱼不如授人以渔, which is, giving a man a fish is not as good as teaching him to fish. But, reinforcement learning and reasoning model, agentic inference model, we want to go one step further. That is, not only we teach him how to fish, we go further. We teach him the taste of fish. Now we make him hungry. We basically motivate the model to learn. That's the key progress that we are seeing in training our future models. So I mentioned several times about reinforcement learning. So in the past, when we talk about scaling law, we really talk about pre-training, training based model. But in post-training and in reasoning model training, really talk about reinforcement learning. So today we are GPT-4 or GPT-5 or Gemini 3. A lot part of it is sorry, focus on pre-training. So pre-training is a large part of training process and in terms of data usage and in terms of computing power. And reinforcement learning and post-training is small part of it, but that has changed since GPT-5 it definitely has changed with Gemini 3 and with DeepSeek's V3.2. That is, reinforcement learning become much bigger part of the entire model training. And the projection is it's going to be much larger than pre-training itself. So post-training of the reinforcement training is going to be much bigger part of it. Think about this. That is, it's not too difficult to understand that once you have the base model, you basically have a very strong knowledge model. And based on that, you want to adapt to different tasks. That is post-training. And that itself, it's like, when after we graduate with undergraduate degree, really we want to get into practice. There are a lot more learning we should do. So that's reinforcement learning. So following this line, we already shift from scaling base model to scaling reasoning to agentic inference. So if that's that entire turning started from O1 model, which was released by OpenAI a year ago in September 2024. And ever since then, we see reasoning model has progressed so fast. And as of today, if we look at the token consumption from October, from September, the token consumption of post-training or reasoning model has surpassed base model. That's a significant turning point. That is to say that reasoning become or performing a certain reasoning task become much bigger part of the model use, and it's going to continue that trend. So then it comes to what I mentioned earlier, but I want to talk here more, is scaling agent or scaling reasoning model. It has a long way to go, and it's a progress so fast. Really here, we talk about scaling, we talk about the capability of thinking, of performing a task in a longer term, long time period. Basically, you can think for a longer time. That's the thinking capability. And we already observe that the length of thinking of task is as a measure using that, it's a measure of agent capability. That capability has been doubled every 7 months. You think about that.
Sorry, Hongjiang, I hate to stop you, but you have 2 more minutes.
Yeah. So and then we have also seen this this trend that the boundary between model and agent, that we think we turns in the traditional, we tend to think that agent is a tool to use model, but that boundary has been blurred as model itself becomes so important, powerful, and performing so much task in terms of agent inference. Okay, so given the progress, given the rapid improvement of AI models capability, we are enter into, from we view AI as a tool to now we view AI as an assistant, and to future we're going to see AI as our partner. So a agent is going to take over the workflow of enterprises, and initially we will see human design agent to replace existing workflow, but in the future we will see design of workflow around agent. So that will lead to what I see the agent economy. So the entire economy will be run, and in the past it is run by organizations, by humans, but in the future is still going to run by organizations, but by organizations of agent. So those agents will form a network, just like today's neural network, and that will become the essence of economy. We call it the agent economy. And so if we look at the model today, we see it, especially pre-training model, we basically look at them for answers. But in the future, we look at those models for to perform complex tasks. That's where we're going. And so think about the future enterprises. Today, when the enterprise is doing very successful, and we want to expand its revenue, scale, what do we do? We hire more people. In the future, what are we going to do? We basically buy more GPUs. We enhance our models, and we create more data. We train more powerful agent, and those agents will scale up the business of this particular company, and that's what I call agent economy. Then the question is, at the agentic AI age, how could enterprises keep its competitive edge? Of course, you need to have computing power. You need to have
Hongjiang, the
powerful
last minute.
data. You need to have more powerful model. But the essence here is you have to have your own foundation model that captures the firm's tacit knowledge. That's the only advantage you would have, because otherwise, all the general foundation models has captured all world's knowledge, can reason very efficiently. How do you get your today's data, enterprise analogy into your own proprietary foundation model? That's the challenge. But that's the challenge a company has to take moving into agentic economy. Okay, thank you. I'm sorry for overrun.